3 by 3 magic square. We want to look at how we can use the rule of 45 degrees in filling the entries of a 3 by 3 magic square, or probably the odd magic squares. 3 is odd, right? So 3, the rule of 45 degrees is applicable to the odd magic squares, right? Okay, now we going to input 1 2 3 4 5 6 7 8 9 in a 3 by 3 square array or 3 by 3 magic square. And if we're talking of 3 by 3 magic square, that is where we input the figures or the values given to us in a square array such that the sum of each of the rows, the columns, and the diagonals of our squares are always going to be identical or the same, right? Such that we have a magic constant. That is what we're going to do. And if this is your first time of hearing magic squares, then this is how you can draw magic, the 3 by 3 magic square. The first 3 that we have is the number of rows that your square should be having, and the second 3, the number of columns that your square should be having. So looking at the square that we have constructed here, we have 3 rows, 1 2 3, and 3 columns, right? And each of the entries of the rows and the columns should be 3, since we're talking of 3 by 3 magic square. If you were talking about 4 by 4, then my rows should be how many? 4. Okay, my rows should be 4. And then my columns too should be what? 4. And the entries of each of the rows and the columns too should be 4. The same thing applies to 5 by 5 and so forth. But in this example, we're considering 3 by 3, and this is the drawing for the 3 by 3 magic square. Now it's left with the inputting. When to input these values, I cannot just start writing 1 2 3. We are having nine inputs, and the entries in a 3 by 3 magic square, they're also 9. But when I just start by writing 1 2 3 4 5 6 7 8 9 in these entries, I'm not really sure that the summation of each of the rows are going to be identical. The summation of each of the columns are going to be the same, as well as that of the diagonals. If you're talking of magic square, then when you're down inputting the values, if you're down filling the entries with the inputs given to you, when you sum the rows, each of them, you should get the same, constant sum. And the columns, you should get the same constant sum that you had for each of the columns, and it should be the same as that of the rows. When you sum the diagonals, you should get the same, constant sum for the diagonals, and this constant sum should be the same as the constant sum that you had for the columns and the rows, right? So without wasting my time, let us look at the rule of 45 degrees. So to consider the rule of 45 degrees, our entries, our first entry is 1, and we would like to write our first entry 1 in the middle square. Okay, so actually this is our main 3 by 3, but I'm going to be using this one as an experiment for you to really understand it well, right? So after everything, we will transfer the figures to the values that we had in the experimental one into this. But when you do understand it, there's no need to draw 2 3 by 3 squares for inputting or arranging these inputs in a square array. You just can do it straightforward. But since probably this might be the first time, that is why I want to use a different one to show it to you. Now our first entry is 1. It could be written anywhere. Okay, it could be written anywhere, but for the basic, try to write it at the upper, the first row, the middle, on the first row, the middle square. Okay, now if we write our 1, and you're considering the rule of 45, you know, if I have that, you see this is 90 degrees according in angles, right? And then if I divide this 90 degrees into 2, then here it will become what? 45 degrees. This place will be what? 45 degrees, isn't it? Yeah. So here, when you write after writing any entry, after inputting any figure in the spaces, what we need to consider is the right upper corner of that particular square. So this square, of which we have input our first value 1, the right upper corner of this, you know, the right upper corner of this is here. Okay, so we need to consider 45 degrees. 45 degrees is going to look like that, just as we demonstrated here, right? Now when you consider your 45 degrees, you also need to consider something. The 4 directions, the cardinal points. You know, we do have the north, the east, the south, and the west, right? So on the upper right corner, you're going to move 45 degrees. Now this 45 degrees movement, you'll be looking at 4 sides: the north, the south, the east, the west, to see if there are any entries. Okay, because after 1 we need to input the next figure, which is 2. But where am I going to write a 2? So the rule of 45 is going to help me in doing that. But when I look at this point, if I look at my north, there is no entry there. My west, there is no entry there. My east, there is no entry there. But south, there are entries, right? There are entries. The 45, there are entries. The immediate entries, that is what we're considering. So since there are entries, I need to write my 2, the entry that I'm having. Now you see, we have 1, 2, 3 coming downwards. Where am I going to write a 2? Please, we don't write it on the first entry. You have to move on to the last entry that you can get. Okay, the last entry. So after any direction, move on, write the next value at the last entry of which you think probably you can write a figure there. So the south, there are entries, but the last entry is going to be here. Okay, so I'm going to write the 2 here. You see that after writing a 2, the right upper corner of this square is here. So I consider my 45 degrees again. It shouldn't be longer. We're considering the immediate, you know, the immediate square. It doesn't mean I'm going to draw a longer, no, just the immediate square. So something shorter, okay, something shorter. And just as we said, we need to consider four directions, right? So my north, if I consider my 45 like that, this is my 45, right? The north, let me draw it again. The north, we don't have anything there. My east, I got nothing there. My south, I got no entries. But look at the west. There are entries at the west, right? Now, where you see that there are entries, we don't write the value following right on that box or in that box. We write it at the last entry, the last box of the entry. Okay, and the last box is what? The last square is what? Here. So this is where we realize that there is an entry but we need to move on to the last one, which is 3 here. Please, do you see that? Okay, now on this square where we have written a 3, the 45 degrees is going to be here because the upper right corner is here, so we're going to consider the 45 degrees here. But look, my 45 degrees, if I draw it, it's in a square already, okay, and that square that it is in it is already having an entry. So what are we going to do when you have such situation? You need to write the figure or the next value below that square. So from 3 we go to 4, and the right upper corner of this square is here, okay, and the 45 degrees we're going to get, it is right inside another square, and that square has no entry. So since it is already inside a square which has no input, then we can write the next input there, which is what? 5. Now this square 2, considering this square 2, the top, the right upper corner of this 5 is here, and the rule of 45 degrees, if I try to control it, it is already in a square, and this square has no entry. So from the 5 I'm going to write the next input, which is 6, right? Now for my 6, the right upper corner of this of the box of which the 6 is in is here, okay. So if I construct my 45 degrees, I think now there's no need to draw the cardinal points. You can see that if I draw it moving to the north, there is no entry. Moving to the, okay, let me draw it. Okay, let me draw it. So to the north there's no entry, to the west there's no entry, to the south there's no entry, and to the east there's no entry. So when you face such situation, what you're going to do again is the same thing that you did for the 3, where you realize that there was an entry, but that entry is already filled. So you need to write the next figure below that. You know, they say the 45 degrees. When we consider all the directions, there are no entries. Then we need to write a figure below it, which is what? 7. And you know, after writing the 7, then we need to consider the upper right corner of the square, and the upper right corner of this square is where? Here, okay, here. So 45 degrees we have constructed it. So we need to look at the 4 sides. North there's no entry, east no entry, south no entry. Look at west, there's an entry, but we need to write it at the last, okay. Unfortunately this place is already filled with 6 here, 1, but the last is blank, so we're going to write our 8 there. From 7 we get to 8, okay. And then on the square of my 8, the rule of 45, the upper corner, the right upper corner of what? This square is here, right. See, we have upper corner, we have 1, 2 corners of this square, but we were looking for the right one. So this is left, this is right. So the right upper corner, you construct at 45, and the 45, you know, when we're moving the corner point, the north there's nothing there, the east there's nothing, the west there's nothing, but the south there is an entry, and the immediate entry, it is already filled. And even if it is not filled, you're not going to write it at the immediate entry, we should write it at the last what? Last entry. So from 8 we go to what? 9. Let me write the 9. From 8 we go to what? 9. And you see, we are done filling the magic square. So this square was just to show you how it is done. Now let us assume that you now do understand it, so you're going to do it in the finalized, magic square table. My first entry is 1, so rule of 45, there's entry here. Okay, so I need to write it down with the last one, which is 2, upper right corner. Okay, so there's going to be an entry here as you move to the last one, which is 3. Okay, the upper right corner here by 45 degrees, there's an entry. Then I need to count below it, which is what, 4 on the upper right corner. So it's already in a box and there's nothing there, so I just write 5. The upper right corner, there's already a square there, and that square got no entry, so I have 6. Right now, the upper right corner, when I look at my north, there's nothing. The south, there will be nothing. The east, there will be nothing. The south, so I'm just going to write it downwards, which is 7. Okay, now the upper right corner of this square is here. Okay, so when I draw my 45 degrees, there's going to be an entry here, which is what, 8. Now my upper right corner is here. Okay, and there's going to be, if I draw my 45 degrees, there's going to be an entry here, the last one, which is what, 9. Okay, so when you finish, 9. Why? Okay, when you finish, for you to be confident that you arrive, then you should have a magic constant. And I believe now you do understand magic constant. The magic constant, that is to say that the sum of each of your rows, each of your columns, and each of the diagonals, they should be the same. So let's check the rows. The first row, 8 plus 1 plus 6, that's going to give us 15. 3 plus 5 plus 7, 15. 4 plus 9 plus 2, 15. So the rows, each of them, we had 15. The columns, so the first column, 8 plus 3 plus 4, 15. 1 plus 5 plus 9, 15. 6 plus 7 plus 2, 15. So the columns, each of them, we had 15. Now we do have the diagonals as well. So the forward diagonals, we do have 6 plus 5 plus 4, 15. The backward diagonal, we do have 8 plus 5 plus 2, that's also 15. Now you see the sum of each of our rows are identical, columns identical, the diagonals identical, and the rows, the sum of the rows, each of the rows, the columns and the diagonals, they must be all the same. And we realize that it is what our feeling that we've done here really obeys that, and you can say that our magic constant is 15. We've done filling or inputting the values here in our 3x3 magic square. If you find this video interesting, you subscribe to the channel for more outside